Hello friends, so here is another question. So it has been given that two insulated charged copper spheres A and B have their centers separated by zero point 0.5 meter. What is the mutual force of electrostatic repulsion between them if the charge on each sphere is 6.5 into 10 to the power minus 7 Coulomb? That is the first part. Then another part is, what is the force of repulsion if each copper sphere is charged double the amount above the amount and the separation distance between them is halved? And then another second bit of the B part of this question is that what is the force of repulsion if both the spheres are placed in water, and it is given that the dielectric constant of water is 80. Okay, so first we should write the given information in one section. What is given? What is the data which is given? It is given that two spheres, they have charge equal to 6.5 into 10 to the power minus 7 Coulomb, and the separation distance, the gap, is 0.5 meter. Okay, so two charges A, B, they are separated by 0.5 meter. So basic application of Coulomb's law here. So as they are like charges, they will repel each other, and is given by 1 by 4 pi epsilon 0 qa qb by r square. So here qa and qb, they are equal, so that's why it will become, this 1 by 4 pi epsilon 0 will simply write as 9 into 10 to the power 9. I have already told you that 1 by 4 pi epsilon 0, when this absolute permittivity is replaced with its value 8.854 into 10 to the power minus 11, the value of pi, and 4 it is substituted, we get this value. So always remember this, that is equal to 6.5 into 10 to the power minus 7 whole square, because qa and qb, they are equal to this, divided by 0.5 meter whole square. So this value is coming around, if we calculate, it is coming around 1.5 into 10 to the power minus 2 Newton. Okay, this is the first part of the question, A, the A bit. Then it has been given that the sphere, on each sphere A and B, the charge is doubled. Okay, the charge is doubled. So the new charges, they are q dash A is 2q and qb dash is also 2q. If we write it as q, qa and qb, that is equal to q, then this equation becomes 1 by 4 pi epsilon 0 q square by r square. Okay, because if we substitute qa equals to qb and write this thing as q, this equation will become like this, 1 by 4 pi epsilon 0 q square by r square, this. So here both these charges qa and qb, the new charges, they are doubled, 2q, 2q, and the distance between them is half. The new distance is half of the original distance. So if we substitute all of these values in this equation of Coulomb's law, it will become 1 by 4 pi epsilon 0 2q into 2q by r by 2 whole square. Okay, this becomes 1 by 4 pi epsilon 0 4q square by r square by 4, that is equal to 1 by 4 epsilon 0 16q square by r square, or we can write it as 16 into 1 by 4 pi epsilon 0 q square by r square. Okay, so if we compare this, okay, this expression which has value equals to this much, okay, this expression 1 by 4 pi epsilon 0 q square by r square which has value equals to f, and this expression, okay, this 16 into 1 by 4 pi epsilon 0 q square by r square, this is equal to 16f, it is equal to 16f. Okay, so the new electrostatic force of repulsion, okay, the new electrostatic force of repulsion is 16 times the original force, the previous force F, which is equal to this. So it is 16 multiplied with 1.5 into 10 to the power minus 2 Newton, which is equal to 0.24 Newton, the new force F dash, let's call it. So simply what we did, we substituted the values. The new charges are twice the original charge, the previous charge, and the distance between them is halved. So when we substituted these values here, we got it is 16 times the previous value, 16 times of this, and we got this, the result. Okay, so this is this part, the first part of the B bit. Then the second part is to find the electrostatic force of repulsion when the two spheres are placed in water. Now we know that Coulomb's law is expressed as the electrostatic force of attraction or repulsion between two charges 1 by 4 pi epsilon 0 q1 q2 by r square. This is when the two charges they are placed in air, but when they are placed in any other medium, then the electrostatic force is given by 1 by 4 pi epsilon 0 epsilon r q1 q2 by r square, or it can also be written as 1 by 4 pi epsilon 0 k into q1 q2 by r square, where epsilon r or k is the relative permittivity or dielectric constant of the medium. Okay, this. So here the force of repulsion between the two charges when they are placed in water will simply be 1 by 4 pi epsilon 0 k into qa qb by r square, which is equal to 1 by k into 1 by 4 pi epsilon 0 qa qb by r square. This part we have already calculated. This part we have already calculated in the first bit of the question, this one, which is equal to 1.5 into 10 to the power minus 2 Newton, this one, because qa qb is this much. This is for the original question, which is qa qb is equal to 6.5 into 10 to the power minus 7 Coulomb, R is 0.5 meter, everything stays the same, only the medium becomes water instead of air. So that force is 1.5 into 10 to the power minus 2 Newton. So when they are placed in water, it becomes 1 by K times 1.5 into 10 to the power minus 2 Newton. Okay, and that is equal to 1 by 80 into 1.5 into 10 to the power minus 2 Newton, because it has been given that the dielectric constant of water is 80. So this value is equal to, it is coming around 1.875. So if we round it off, it becomes, let's say 1.9. It is coming 1.88, 1.8788 like that. But if we round it off, it becomes 1.9 into 10 to the power minus 4 Newton. This much. Okay. So this is the solution. So again, this question was based on a Coulomb's law. It was based on Coulomb's law, but a lot of other concepts also came into play. The concept of relative permittivity, dielectric constant, also how these parameters, that is the magnitude of the charge, the separation distance, how they affect the electrostatic force of attraction, repulsion. The force is directly proportional to the magnitude of the charge, inversely proportional to distance, that we have discussed, and theoretically now we understood it practically through numerical problems, and about basic concept of Coulomb's law. Okay.